Here we are, the last section that we're going to do in this course. Unit step functions. These are functions that are going to allow us to use Laplace transforms to solve differential equations that involve non-continuous functions. So here we go. The unit step function, there's the c, the subscript, is going to determine which unit step function it is. So u sub c of t is equal to 0 if t is less than c, and it's equal to 1 if t is greater than or equal to c. Here's the graph right here, 0 up until you get to c, and then it pops up to 1 and stays there forever, I guess. I think of it as the turn on function, right? That this thing is off, and then when t increases up to c, then it turns on, and from that point on it stays on. Likewise, you could do 1 minus u sub c of t, which would be the turn off function, right? So if this is u sub c, then 1 minus 0 would be 1, or 1 minus 1 would be 0. So this is on to start with, and then when you get to c, it turns off to 0, and there you go. Now we can do combinations of them. For instance, if I add u2 of t minus u5 of t, I get something like this. When t is less than 2, both of these things are 0, and 0 minus 0 would be 0. As soon as you get bigger than 2, then this one turns on to a 1, and 1 minus 0 would be 1. But then once you get bigger than 5, and both of these are turned on, the 1 minus 1 comes back down to 0. Okay. So we can make combinations of these unit step functions to do different piecewise functions. So in particular here, let's change this one up a little bit and multiply that whole thing by the function t. So when this is 0, t times 0 would be 0, but when this is 1, t times 1 would be t, and you'd be looking at that piece right there. And then back to 0 again, when t is bigger than 5. So it's not just flat-topped things that we can do, but we can actually do any piecewise function using these unit step functions. For instance, here is a function, just making up a random piecewise function here, t plus 6 if t is less than -2, t squared if t is between -2 and 1, and then t minus 4 if t is bigger than 1. So the graph of that, of course, is over here. And I have two ways that I think about how to do this using these unit step functions. So the first way is just this idea of turning on and turning off. Right? So when I say t plus 6 times 1 minus u negative 2 of t, this is saying that, so the 1 minus, this is the turn off function, right? This is on until you get to -2, and then it shuts off. So this is 1 and then 0, and when you're multiplying by the 1, you're seeing the t plus 6, but then you get to -2 and it shuts off. Then here I've got the u negative 2 of t minus u1 of t, so this is turned on between -2 and 1, and that's being multiplied by t squared. So where this just shut off at -2, this now turns on at -2, so you're multiplying by t squared there, and you see the t squared piece. Then at 1, this shuts back off, but I have this one turning on at 1, so you see the t minus 4 once t is bigger than 1. Okay, so this is the first way I see it, of just turn on and turn off the thing you want at the appropriate time. Now, another way that people do this is right here, where they would say, hey, this starts off as t plus 6. Right? This is t plus 6. But then at -2, I'm going to do a couple of things. Right? At -2, I'm going to add in a t squared, but I'm going to subtract out the t and the 6. So turning on t squared minus t plus 6 essentially shuts off the t plus 6 and turns on the t squared. Right? Then when you get to 1, you're going to turn on -t squared plus t plus 4, so the t squared gets turned off again. It was here, and then now I'm subtracting it, so it's gone, and I'm just left with a t plus 4. Now this you can think of it that way to build the function itself, or if you build it this way, which is actually the way I think about it, then I can distribute stuff and collect like terms, and it ends up looking like this. They are the same function. So what we're going to need to do next is look at Laplace transformations of these things, and then finish with seeing how they help us solve different types of differential equations.